Okay, guys, we're going to look at trig ratios. So that's our sine, cosine, tan. We're just going to deal with our primary trig ratios today. And we're going to do it for any angle between 0 and 360. Okay? So remember, let's not forget, sine angle, remember, is opposite over hypotenuse. Cos angle, remember, is adjacent over hypotenuse. And tan angle is opposite over adjacent. We also have special triangles, so let's not forget those. So we have our 45 degree 1 root 2. And we have our 60 degree 30 degree combination that looks like 1 2 root 3. Okay, so we're going to use all of these pieces today. So what we're going to do first is we're going to do what's called drawing an angle in standard form, or standard position, sorry. 1. Draw angle in standard position. So what does this mean? So we could do it very abstractly, and I have another video for abstract, but let's just stick with examples today. Okay? I think it might help to keep it less crazy. So let's look at the angle. 315 degrees. Okay, so where is 315 degrees? Let's see. If I draw an XY axis, and if I start at X is my 0, so this is where I start. I go up to here. Well, here is only 90 degrees, so we got to keep going. Come around to here. Well, the straight line is 180, so we got to keep going. All the way around to here. Well, 90 plus 180, that means I'm now at 270, so I'm still not there yet. I got to keep going. All the way around. And if I went all the way to the end, well, a full circle is 360 degrees, so I don't want to go quite that far. So I'm going to end up ending somewhere in here. Okay, so where I end, this is called my terminal arm. Okay, where we start, oops. Okay, so our initial arm is here because we start here, the initial arm. Notice how we went counterclockwise, so we have to go counterclockwise. So that's going that way around. And this angle here, so that angle that we just drew out, well, that's my theta. Okay, so there's my principal angle that we're talking about. Okay, principal because it's the one we're talking about. But what happens is that it ends up making a really nice, hold on, this word's in my way. It makes a right angle triangle with the x-axis here. Okay. And you have to make it with the x-axis. That's important. Okay. I'll put my initial arm back on. So let's recap. Start at 0. That's my initial arm. Rotate around counterclockwise, land on our terminal arm, and then what happens is we make a right angle triangle with the x-axis. Has to be with the x-axis. Okay, and then inside here, notice how that's an acute angle. So we call that beta. So that little angle beta is called the related acute angle. And to find it, it's going to depend on where the which quadrant we're talking about. So in our fourth quadrant here, remember if we went all the way, we'd go to 360. So 360 is going to be equal to our 315 plus whatever beta is. So beta is going to be equal to 360 minus the angle that we were dealing with. So minus our theta. Maybe I should set that step in. So that means it's 360 minus 315. So in this case, I'm now dealing with, hey, look at that, a 45-degree triangle. So this little triangle in here is actually going to be a 45-degree angle, which is one of our special triangles. So let's keep going with this question. We're not done. So far, we've just kind of been figuring out what we're dealing with. So I'm going to take my little triangle here, and I'm just going to redraw it down here because I've already made a giant mess up there. So there's my 45. There's my right angle. So my 45-degree triangles, remember, are 1, 1, root 2. Okay? So that means that when I go to write this into my trig ratios, there's my opposite, there's my adjacent, there's my hypotenuse. So we can write it all out. Also, let's not forget the fact that we are below our x-axis. So my y value is actually going to be a negative value. Okay, and that has to be the case because, right, if there's my x and there's my y, I'm down in the negative y values down below. Okay, so let's write them out. Sine angle is opposite over hypotenuse. So that means sine angle is going to be negative 1 over root 2. Cos angle, oops, I didn't write that right. Hang on. Okay, let's try that again. Sine angle is opposite over hypotenuse. So that means that sine, oh boy, of 315, that's what I was missing before, is negative 1 over root 2. Cos angle, remember, is adjacent over hypotenuse. So that means cos of 315 is going to be positive 1 over root 2. And tan angle, remember, is opposite over adjacent. So that means that tan of 315 is going to be equal to negative 1 over 1, which gives me a final answer of negative 1. So what's happened is I'm getting the same numbers as I would have gotten for my 45-degree triangle. It's just now some of them are going to be negative. So I've got a negative sine, a positive cos, and a negative tan. Okay? Okay, so let's do the same example, only this time, let's have our angle equal to 150 degrees. So again, we want to draw it. So remember, our x-axis is our 0 degrees, right? Y-axis is 90 degrees. Negative x-axis over here is 180. Down to the bottom is 270. Bring it back to the start, that's 360. Okay? So 150 is going to land somewhere between 90 and 180. So let's just draw it here. So that means that our angle, so our principal angle is here. And that means that our related acute angle triangle, you have to draw it with the x-axis, is going to be in here. So beta, remember, is our related acute angle. And this time, we're not quite making it all the way to 180. So we've got our supplementary angles here. So 150 plus beta is going to equal to 180. So beta is going to be 180 minus my principal angle. So what's 180 minus 150? Oh, there's a 30-degree triangle. Oops, sorry. So this is going to be one of my 30-degree triangles. So that means this angle in here is going to be 30 degrees. So that's my beta right there. That looks funny. Okay. So again, let's see. So a 30-degree triangle means root 3 is next to it. It looks at 1 and its hypotenuse is 2. Now watch your pluses and minuses. So right now we're going up the y, so the y is a positive, but my x is now going to be negative. So let's write our trig ratios for it. So we know, hang on, give myself some space here. Sine angle is opposite over hypotenuse. So that means that sine of 150 is going to be equal to positive 1 over 2. Positive 1 over 2. We know cos angle is adjacent over hypotenuse, so that means cos of 150 is going to be equal to negative 1/3 over 2. What did I say? Negative root 3 over 2. I don't know what I just said. And tan angle, we know, is opposite over adjacent, so that means tan of 150 is going to be equal to opposite is 1 over negative root 3. So my tan value in this one is going to be negative. So notice what happened again. We've got the same ratios as we get for a 30-degree special triangle, right? It's the same triangle as this. And this time, sine is positive, but cos and tan are negative. So this kind of brings me to our next really awesome thing to add to kind of like our toolbox here. And it's this thing called CAST. So CAST is an acronym. To recall which trig ratio is positive in a specific quadrant. Okay, so what do we mean by that? So here's my xy quadrant. There's my x, there's my y. So we've got quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And in there, well, all of them are positive here. So all are positive. So sine, cos, and tan are all positive in this quadrant. Sine is positive over here, but that's the only one that's positive. The other ones are negative. Tan is positive in that quadrant, but sine and cos are negative. And who's left? Cos is positive in this quadrant. The other two are negative. So that gives me my CAST, C-A-S-T. Or if you're local, all students go to the Sudbury Theater Center. Cool, eh? Okay, so let's try this example. We want to find all angles between 0 and 360 that satisfy sine angle equals negative 0.123. Okay, well, we know how to use our calculators, right? Like, to bring sine to the other side, don't we just have to do second function, sine inverse, type all that in, right? No big deal. Look, I've got it all typed in, ready to go. Enter. Oh. Well, what does that mean? It's a negative. What is that? Okay, so I just wrote down what our calculator told us, but like, what? What does that mean? Well, glad you asked. So, remember the part about how standard angles go counterclockwise? Negative angles come this way. So negative 7 degrees is going down. So what does that mean? Well, let me just adjust us here. So let's think this through. Here's my axis there. There's my negative 7 degrees came down this way. Okay, so that means that my beta inside here, my little related acute angle, is 7 degrees. Well, if that's 7 degrees, can we figure out what my real big angle is that I'm actually looking for? Definitely. So that's going to be 360 degrees minus 7. So my real angle that I really want is going to be 353 degrees. Now, is that my only answer? No, it is not. Because that's not the only spot where sine is negative. So we need another quadrant. So we just did that quadrant where sine is negative. So my other quadrant where sine is negative, well, it can't be this one because here everybody's positive. Here's my S, which means sine is positive. So it's got to be down here. So I still have that same beta of 7 degrees. And this time, the angle that I want is going to come all the way around that way. So it's going to go past the 180, an extra 7 degrees. So there's theta 1. So theta 2, which is this picture, is going to be 180 degrees plus 7 degrees. So it's going to total 187 degrees. Oh boy. So I get 2 answers. And this is going to be true for just about every single one of these types of questions. You have 2 possible answers. And sometimes your calculator doesn't give you either of them. Okay, so you got to be aware. All right, let's finish off with one last example. So in this case, I want to find all angles between 0 and 360. And this time I'm telling you I want tan theta equals negative 1 over root 3. So this 1 over root 3 is actually telling me what my triangle is going to be. So I want all my angles. And you know what? Let's write all of our trig ratios. Okay, just to finish it all off. What are our trig ratios going to be? So when we look at this, let's see. Tan, remember, is opposite over adjacent. So my opposite is 1. My adjacent is root 3. Okay, so let's draw it out. Draw it out. Always draw it out. Totally helps if we draw things out here. So let's see. Tan is negative. So according to cast, well, it can't be here because everybody's positive there. Can't be here because that's when tan is positive. So I'm going to have 2 answers. One answer is here. And the other answer is going to be down here. So I'm going to have 2 answers because tan is going to be negative in both of those. Okay. And then when I go to draw out my triangle, oh, I just made myself a mess. Let's just tone it down here real quick. I'm going to take this one back off. And we'll come back to that one. When we go to draw it all out, here's my triangle. And if my opposite is going to be 1, and if my adjacent is going to be root 3, and since it's over here, that's the one that's negative, well, I now have my 1, 2, root 3 triangle, and my 1, 2, root 3 triangle is this one. So let's see, root 3 is on the bottom, so that means this is a 30-degree angle in here, which means my full angle has to be 150. Oh, didn't I already do this one? Oops. Oh, well. So my theta is going to have to be 180 minus 30. So that angle is going to be there. Okay, let's skip the trig ratios. I don't want to do that one too. This is a big enough question as is. And our other one, I'm just going to redraw that triangle so it's not quite so messy. So we said it has to be down here because it couldn't be there because that's positive. We just did that one. And it can't be here because that's when tan is positive. So we have to come all the way around to here. And that 30-degree triangle is in here because, remember, opposite has to be 1, adjacent has to be root 3, only this time it's my opposite that's the negative. That's going to be 30. Then our angle is going to be 360, because that's all the way around, minus the 30, because we have to come back, right? So our second angle is going to be 330 degrees. Cool, eh?